this is the third video for homework help for Chapter 7. In this video we'll look at the student's t-distribution. In the previous lecture on the z, for the z values, in that case it was presumed that you knew the standard deviation for the population. And you might say, if I know the standard deviation for the population, obviously I know the mean. So if I know the mean, why am I worried about what interval it lies in? I know it. And you're right about that. Many of these problems are included in the textbooks for practice. They aren't very realistic problems. They could be used to test the value of a sampling method. But generally the more realistic situation is that you do not know the mean or the standard deviation for the population. That is why you're doing the sampling. In that case, you can use something called the student's t-distribution. This t-distribution is a group of curves that look more or less bell-shaped. They're symmetric, but they aren't bell-shaped. The difference in the curves depends on a parameter called the degrees of freedom. Degrees of freedom, or DF, you can see DF right here. That means degrees of freedom. The degrees of freedom is the size of the sample minus 1. So for the example where you had 25 CDs, you were pulling off the assembly line. If you pulled off 25, then the degrees of freedom would be 24, because it's one less than that. If you were measuring something, trees, and you were measuring 10 at a time, then N would be 10 and the degrees of freedom would be 9. So you can see a group of these curves here. In this case, the degree of freedom is 1. That means that the sample size was 2. You're measuring two items at a time for each sample. And that's this curve down here. Okay? As the degrees of freedom increase, all the way up to theoretically infinity, these t-distribution curves become more and more like the bell-shaped curve. So this one would be, oops, don't have the pen. This one would be actually a bell-shaped curve. So anytime you try to compute the t-distribution, you have to find the degrees of freedom, and the degrees of freedom are the sample size, the number in each sampling, minus 1. The confidence interval for the t-distribution looks just like the confidence interval for using the z values. You take the mean for your sample, you add or subtract so many standard deviations. Here, this S is the standard deviation for the sample. Here, this sigma was the standard deviation for the population. You divide by the square root of the sample size, same in both cases. Okay. Here you multiplied by that z value, now you multiplied by the t values, t alpha over 2 as opposed to z alpha over 2. So you have the exact same formula you're going to plug into, but you have to use the t values. To find the t value, you must find the degrees of freedom. Then you look in the table in the back of the book and get the values. Here's an example. Say you knew that the mean of the sample was 36.2 and the sample size was 15. So N was 15. And that the standard deviation for this sample that you measured was 5. So here you have all your data. I'm going to write that in a list. I know that N is 15, the mean for the sample is 36.2, and the standard deviation, standard deviation for the sample was 5. Because I know that N equals 15, the degrees of freedom are 14. So you go to table F, which is in it's in Appendix C in the book, or it's also reprinted in the last page of the textbook. And you look up for 14, and you look at the confidence interval for 95%, and you look down and find the degrees of freedom of 14, and you find a t alpha value of 1.761. Then you take that formula before and you plug into it. Let me write the formula here for you. It was x bar minus t alpha over 2 times the standard deviation divided by the square root of n, and the population mean was lying in there. So here's x bar plus, same thing, t alpha over 2 s over square root of n. And now you see how that things got plugged in there. You need the sample mean, so you put it here and you put it here. Okay, the t alpha over 2 was 1.761. You see it appears here. And then also on this side, whoa, there's an error there. Let me correct that. There should be a plus. Okay. Then you have the sample mean. And that goes right here. And you divide by the size, the square root of the size of the sample. So here's your square root of 15. You work that out, and once you work out the arithmetic there, you find that the population mean with a 95% confidence lies between 33.93 and 38.47. And now you should be able to do some of the homework. I asked you also to look up the history behind the term students. Why is it called students? Kind of interesting. You can look that up. Write the equation for the degrees of freedom in terms of the sample size. Well, degrees of freedom is the sample size minus 1. That's easy enough. Then there were a few problems to find the t alpha over 2 values, looking in Table F in Appendix C or on the last page of the textbook. So if the sample size is 29, then you know that the degrees of freedom is 28. And you want a confidence level of 80%, so you look under the 80% column down to where you have the degrees of freedom equals 28, and from that you will find the value of t alpha over 2. And now you could work out a confidence interval using a t-distribution. So first write the equation down so you know what's going on with it. So here was that equation. I just wrote it in here. You can copy it from here. This is what you've got to be able to plug into. This gives you the confidence interval once you work out the arithmetic. And now you can find the confidence interval for the following parameters. You have a sample with its mean of 55.6. It has a standard error of 2, or standard deviation of 2. There were 24 in the sample size, 24 objects, so that sample size is 24, and you want a confidence level of 98%. So you use these two pieces of information to find your t alpha over 2 value, and then you plug everything into this equation and you work out the arithmetic and you find the interval which would contain the population mean with a confidence level of 98%.